Hello, this is Marcos Katz. I'm a professor of wireless communication from University of Oulu in Finland, and we are here today at KU Leuven at a meeting of our SuperIoT project. SuperIoT is an Horizon Europe project focused on the development of a truly sustainable IoT system. In the project, we exploit radio and optical technologies to provide connectivity to reconfigurable IoT nodes. Light and radio are also exploited to harvest energy as well as to provide localization. Since this is a holistic approach to sustainability, we implement the IoT devices using printed electronics technology.
Printed electronics is one way to decrease the environmental footprint of electronic products. In SuperIoT, we are using printed electronics together with more sustainable raw materials like bio-based and renewable substrate materials and abundant inks. And this is one example of a printed product that has been made more sustainable by selecting renewable substrates and using eco-design to design it. This can be used for monitoring constantly conditions of products during their logistics process. In SuperIoT, we want to develop these kind of smart labels to be even more sustainable by combining the printed circuitry and the printed supercapacitor with the organic photovoltaics.
I'm Marcin and I'm from Empicosys. We are low power innovators and partner in SuperIoT project. One of the important tasks of a reconfigurable IoT node can be information display. This can be performed using e-paper. This is electronic paper display and it looks like a normal paper and can actuate the data or human readable information or some machine readable data like QR code, and it can be actuated with use of the minimum of energy.
Hello everyone, my name is João Coelho and I'm one of the team members from SuperIoT, and I'm focused on the development of energy storage devices like this one I'm showing here, that is a micro supercapacitor. Why do we need these energy storage devices? Basically, in the project, we want to use a OPV, that is a type of solar cell, to harvest energy from the environment, and then we need to store it in some unit so we can use it later on. For SuperIoT, I'm developing this kind of micro supercapacitors that are made from materials that are cheap, sustainable, and that can be easily processed without any kind of harsh chemicals or treatment. So we are trying to keep the processing as sustainable as possible. Same thing goes for the substrates. In this case, we have some kind of plastic, but we can do this in paper or another kind of substrates of interest, always thinking on sustainability of the process.
Among other tasks of SuperIoT project is to have a reconfigurable IoT node. And by reconfigurable, I mean to have both technology, radio frequency and visible light communication. We will work here at KU Leuven Wavecore Arenberg. We will work on not only the node itself, but also on the communication protocols where we can switch between these technologies. And we will work on the energy harvesting and communication. My name is Qadir Hamoud. I am a PhD student at KU Leuven, and I work actually with light energy harvesting and communication. So as you can see, we have a node which is purely silicon node, but the idea is to change this to a printed electronic and to have both capability of energy harvesting and communication using the light and the radio frequency.
Hello, we are Julio Rufo and Jose Rodan from LIB, one of the companies involved in the SuperIoT project. We are in an anechoic chamber, which is going to be used for testing some of the elements involved in the SuperIoT technology. SuperIoT project contemplates 4 different demonstrators. One of the demonstrators and applications are related with sustainable tags. Among the applications, we have tags for market products, small tags for animal tracking, or disposal tags for medical application, for monitoring and tracking and identification of patients in a hospital.
Demonstrator 3 deals with printing electronics limited capabilities. In this case, we are trying to develop a fully printed IoT node. Finally, demonstrator 4 deals with large area communications, for example, in forests, in smart cities, in farming, in mining, among others.
We will provide updates on the progress throughout the project, so for more information, please visit our website to keep you updated. You can also subscribe to our newsletter and follow us on LinkedIn and X.